Hello everyone, welcome to our presentation on a fascinating and incredibly useful design pattern in software engineering, the facade pattern. We are excited to share how this pattern can simplify complex systems and improve your coding experience. I am Daim Ali, presenting with Urwa Zamir and Zayan Ahmed. Our guide for this project is Professor Hafiz Anas Bilal. In this tutorial for facade pattern, we would see that why there was need of facade pattern, what facade pattern is. We would provide you multiple examples, their Java code, their class diagram to make you understand about the facade pattern. We would also discuss about the benefits of facade pattern. So let's dive in and explore the magic of facade pattern together. Let's start with an introduction to the problem. Imagine you are working on a project that requires using a complex library or framework. In such a scenario, you need to initialize and manage multiple objects, keep track of dependencies, and ensure that the methods are called in the correct order or not. This complexity makes your business logic tightly coupled to implementation details of the third party classes, leading to code that is difficult to understand and maintain. A facade is created to solve this problem. What facade is? A facade is a class that simplifies interaction with a complex system by providing a straightforward interface. Instead of dealing with all the details and numerous parts of the system, the facade offers a simpler way to access only the essential feature that you need. This is especially useful when you are using a complex library with many features, but you only need a small part of its functionality. The facade makes your code cleaner and easier to work with by hiding the complexity. To define the facade pattern formally, it provides a unified interface to a set of interfaces in a subsystem. The facade defines a higher level interface that makes the subsystem easier to use. This concept is well documented in the book Head First Design Pattern by Eric Freeman and Elizabeth Robson. The key idea is to abstract away the complexity and provide a simplified interface for the client, thereby promoting loose coupling and improving maintainability. So now let's take an example of laptop to understand the facade pattern. To turn the laptop on, its multiple components such as motherboard, operating system, etc. These must should also be turned on. But in real life, when you have to turn the laptop on, you have to only connect through a single button. You have to press that button and the laptop turns on. This button is known as a facade which connect with the multiple classes of the laptop. So the structure of facade is that there is a facade class through which the client connect. This facade class contains the features of multiple subclasses which can be accessed through a single interface. So that's all from my side. Now Urwa and Zian would give you further examples and describe that examples, and they would also provide their Java code.
Today, I will be discussing the problem of managing complex systems in software development and how we can solve this problem using the facade design pattern. We will use a home theater system as our example. Let's start with the problem statement. Imagine you are developing a software for a home theater system. This system includes several components such as a sound system, television, and lights, each with its own set of functions and configurations. Managing and coordinating these components directly from the client code is very difficult and prone to errors. As the system grows, changes to individual components often cause unexpected issues and create tight coupling between the client code and the subsystems. The main challenges here are each component has multiple functions and settings, making it hard to manage them directly. Direct management increases the likelihood of errors. To address these challenges, we can use the facade design pattern. The pattern provides a unified interface to a set of interfaces in a subsystem. It defines a higher level interface that makes the subsystem easier to use, reducing complexity and dependencies for client code. The facade pattern works by introducing a facade class that provides simplified methods for the client to interact with. The facade class interacts with the subsystem classes, handling the complex interactions internally. The client code interacts only with the facade, not with the individual subsystem classes. Here is the class diagram for our home theater system using the facade pattern. The subsystem classes include sound system, television, and lights. Sound system class has methods to turn the sound on and off. The television class has methods to turn the TV on and off, and the light class has methods to dim the lights on and to turn them off. The home theater facade class provides simple methods to control all the subsystems. It has methods like watch movie and end movie that coordinate the actions of the subsystem.
Now we have the Java code for each subsystem of our home theater system. So this is the Java code for the sound system class, which includes methods to turn the sound system on, off, and to set the volume. The on method prints a message indicating that the sound system is on. The off method prints a message indicating that the sound system is off. And the set volume method takes an integer parameter which will represent the volume level, and it will print a message which indicates the new volume level. Next we have the Java code for the television class. Similar to the sound system class, it includes methods to turn the television on and off, as well as to set the channel. The on method prints a message indicating that the television is on. The off method prints a message indicating that the television is off. The set channel method takes a string parameter representing the channel name, and it will print a message which will indicate the new channel. Finally, let's look at the lights class. This class contains methods to dim and brighten the lights. The dim method prints a message indicating that the lights are dimmed, and the brighten method prints a message which will indicate that the lights are brightened. Now let's examine the Java code for the facade class, which encapsulates the interaction with the subsystems. So here is the Java code for the home theater facade class. This class acts as a simplified interface to the complex home theater system. In its constructor, it takes instances of the sound system, television, and light classes as parameters, allowing it to interact with these subsystems. The watch movie methods will set up the process for starting a movie. It begins by dimming the lights, turning on the sound system, setting the volume, turning on the television, and setting the channel to Netflix. Finally, it prints a message which will indicate that the movie is starting. Similarly, the stop watching movie method reserves these actions, turning off the television, turning off the sound system, and brightening the lights. Now the question is why we need the home theater facade class. So the purpose of this class is to simplify the interface for the user. Instead of directly interacting with the individual components of the home theater system such as the sound system, television, lights, user can simply call the methods on the facade class. This abstraction hides the complexity of the subsystems and provides a more straightforward way to control the entire system. By using the facade pattern, we achieve better encapsulation and loose coupling between the client code and subsystems. This means if we ever need to make changes to the internal implementation of the subsystems, we can do without affecting the code that uses the facade.
The facade pattern offers several key benefits. Firstly, it provides a simplified interface for interacting with complex subsystems instead of dealing with multiple components and their numerous functions. The client code interacts with a single straightforward interface. This makes it easier for developers to use the system without needing to understand all the underlying details. Secondly, the facade pattern reduces coupling by decoupling the client code from the specific implementations of subsystems. We promote loose coupling. This means that changes in the subsystem do not affect the client code. As long as the facade interface remains the same, this separation simplifies maintenance and enhances the system's flexibility. Thirdly, it improves maintainability because the facade isolates the client code from changes in the subsystems. We can update or refactor the subsystems without impacting the client code. This isolation allows for easier updates and reduces the risk of introducing errors when making changes. Lastly, the facade pattern enhances code readability. By abstracting away the complex interactions within subsystems, it provides a clear and high level interface. This makes the code easier to understand and work with, facilitating better communication among developers and improving overall productivity.